In this video, we are going to prove through the two-column proof that if inscribed angles of a circle are subtended by the same chord, then the angles themselves are congruent. So we're going to start with circle A, as we usually do. I will just label this center point A, and create a chord. It does not matter what chord we create. Remember, this should be generally true as it's a theorem. So we're going to arbitrarily create this chord from one edge of the circle to another. Okay. We're going to say these are points B and C. And then we are also going to create two inscribed angles. We're just going to pick two random locations. We're going to pick point D on the circle, and then let's also pick point E over here. Okay. We are going to construct then the inscribed angles. Okay. Segment DB, as well as the segment DC. Okay. Segment EB, and the segment EC. Okay. The inscribed angles are here, alpha, and here, beta. Okay. So we're going to list off again with our two-column proof that we have a circle A, as well as our constructed points, chord BC, inscribed angles alpha and beta. Those are given. Okay. So again, our goal is to say that alpha is congruent to beta. That's our end goal for this particular proof. This proof is actually going to be heavily dependent on one that we already used, the symmetric chord example, where we just said the inscribed angle is equal to half the central angle that subtends the same arc. Well, notice the arc BC relates directly to the chord BC. Okay? So what we're going to do is actually draw the radii AB, which will be congruent to AC, which is already partially drawn just based on a poor choice of D. But we're going to draw AB, the radius. Okay. And we now have the angle here, gamma. Okay. This is because radii are congruent. Okay. And gamma is the central angle by definition. Okay, so we're just going to write definition knowing full well we're referring to the central angle definition. Okay. Now we're going to use our theorem before, our inscribed angle subtending the same arc. So gamma subtends the arc BC, okay, as does alpha and beta also. Okay. This is a straight-up definition by visual inspection. There is no inherent deeper meaning to that. Okay. But knowing this, okay, we know that alpha and beta are the inscribed angles to the same central angle. Okay, which means from our prior theorem that gamma, the measure of gamma, is twice alpha, and the measure of gamma is twice beta. Okay. So these come from the inscribed angles subtending same arc as central angle theorem. and I'm writing it, and you may not be able to read it completely, but I will just reread it again. The inscribed angle is subtending the same arc as the central angle theorem. Okay? We're not giving the details of the theorem, we're just stating what theorem we are actually using. Okay? So because of that, gamma is related to 2 alpha and gamma is related to 2 beta. By the transitive property, okay, by the transitive, we can then say that 2 alpha must be equal to 2 beta, and therefore, after simplification, alpha itself is equal to beta. The measures are, which means that they are also congruent, which is what we are originally intending on demonstrating.